All right, in the previous 4 videos, we've come up with the sine, cosine, and tangent angle addition formulas, and then the sine, cosine, and tangent angle subtraction formulas. In this video, what I want to do is use those to come up with the sine, cosine, and tangent double angle formulas. And then once we have that, in the last video, I'll come up with the sine, cosine, and tangent half angle formulas. Both of these will come pretty quickly. So to prove these double angle formulas, which I have written off to the side here, all we'll need to know are our angle addition formulas, which were proved in the first 3 videos, and our Pythagorean identity, which hopefully you're pretty comfortable with at this point. And the trick that we're going to do for each of these 3 will be kind of the same. If we want to come up with the sine of twice some angle A, the way to think about that is that's just the sine of some angle A plus that angle A, right? 2A is the same as A plus A. Yeah, that's true, but why do you write it this way? Well, because if I write it this way, I can use my sine angle addition formula. I take this formula, playing the role of this A is this A, playing the role of this B is this A. So I copy what I see here, except change all the B's into A's. I get sine of A, cosine of A, plus cosine of A, sine of A. Wait, aren't those both just the sine of A times the cosine of A? Yup. So you're telling me I have 2 of these sine of A, cosine of A things? Yup. Wait, isn't that exactly the double angle formula? Yup. Wow, that was kind of easy. What about cosine of twice some angle? Surely it's not that easy. Yep, it's the exact same. We'll think about cosine of 2A as the cosine of A plus A, so that we can use our cosine angle addition formula. Playing the role of this A is this A, this B is this A. Copy what you see here, changing all the B's into A's. I got the cosine of A times the cosine of A minus the sine of A times the sine of A. Wait, cosine times cosine, isn't that just cosine squared A? Yup. Sine of A times sine of A is sine squared A? Yup. Just like that, we have the first version of our cosine double angle formula. You might notice that there's 3 different versions of our double angle formula. The reason why is this can be rewritten in different forms. What do you mean rewritten in different forms? Well, when you see sine squareds and cosine squareds, maybe you're immediately thinking I have my Pythagorean identity. Because sine squared plus cosine squared equals 1, sine squared is equal to 1 minus cosine squared. If I subtract cosine squared from both sides of this equation, what that's saying is I can come down here and I can replace this sine squared with 1 minus cosine squared. Be careful with your parentheses. You got cosine squared A minus, and then this entire thing, 1 minus cosine squared A. Let's see, if I take this negative and distribute it through, this becomes a positive. So I got cosine squared A minus 1 plus cosine squared A. Wait, I got one of these cosine squared A's, and then I got another one of these cosine squared A's. Kind of looks like I have 2 of these cosine squared A things, and then the minus 1. It's exactly what I have, and that's the second of our angle addition formulas. But what if I didn't want my answer to be in terms of cosine? What if I wanted it to be in terms of sine? Well, that's easy enough. I can always change cosine squareds into sine squareds pretty easily. Take this formula and solve it for cosine squared. Subtract sine squared from both sides of the equation, and you get cosine squared equals 1 minus sine squared. What that allows me to do is change this cosine squared A into what I have on the right side of the equation here, 1 minus sine squared A. Do a little bit of distributing. Take this 2 and hit each of these terms to get 2 minus 2 sine squared A. And then don't forget you have this minus 1 out here. 2 minus 1. That sure sounds like 1 minus 2 sine squared A, which is the third and final of the 3 forms that we want for our cosine double angle formulas. Finally, tangent of 2A, guess what? Exact same trick. We'll think about that as the tangent of A plus A, and then use our tangent angle addition formula that you see right here. Playing the role of A and B are this A and this A, so I copy what I see here, changing the B's into A's. That yields this kind of ugly looking thing, but I can clean it up. Tangent of A plus tangent of A, that's just 2 of these tangent of A things. And then down in the denominator, tangent of A times tangent of A, that's just tangent squared A. What I have is my tangent double angle formula, which was the last of the things I was trying to prove in this video.